Vector addition and subtraction in 5 minutes. In the last video, we saw how to resolve vector into their respective components. In this video, we're going to see how to find the resultant vectors if there are more than one vectors. We're going to resolve them and find the resultant of those resolved vectors. That just sounded like a mouthful, right? Don't worry about it. I've got you covered. As usual, the link to this lecture note is in the description below. Check that out and let's get started. Now let's assume that there are two vectors which are perpendicular to each other. We already know how to resolve a vector into two components, which would mean that even if there is just one vector, we would have two of those components which are perpendicular to each other. Now let's assign these things some values. Let me call one of these vectors as ax and the other one as ay. So assigning these values helps us to figure out what would be the resultant vector. Now, the rule for finding a resultant vector, especially when you're adding two vectors, is that the resultant vector connects these two vectors. So that would mean that the resultant vector would look something like this. Now, how would I write this in mathematical equations? So if I represent the resultant vector as r, that would just be the sum of the vector ax and the vector ay. It's as simple as that. Now, the interesting thing about the resultant vector is that the resultant vector also has an angle, right? And I need to find the magnitude of this resultant vector and I need to find the magnitude of this angle. So how do I find the magnitude of the resultant vector? The resultant vector would have a magnitude which is equal to the square root of the square of both of these components, that is ax squared plus ay squared. Now, if I want to find the magnitude of the angle of inclination, because a vector would have a direction and I not have a direction in terms of this figure, all I have is an angle, and if I have an angle, then it would mean that it would point in a specific direction. I can use that angle to talk about a specific direction. So the expression for that would be theta, which is the angle of inclination of this vector. That would be tan inverse of ay by ax. Now, point to remember is that ay and ax are the vertical and the horizontal components of a vector respectively. Now let's learn how to subtract these vectors. Now let's just assume that the same two vectors are given and they are at an inclination of 90 degrees with each other. Now, the only thing that we need to do is we need to find a resultant vector which is a subtraction of these two vectors, that is ax minus ay. Now, what happens in vector addition is that these vectors, the negative sign denotes the direction of the vector. So if I call this as ax and if this is ay, the negative of ay is just that ay in a different direction. So this, another vector, would be called as ay. So instead of trying to subtract ay from ax, what I can do is that I can consider these two as vectors in different direction, and then I can just simply add vector ax and the negative of ay. It's the same as subtracting ay from ax. That would mean that the resultant vector is something on this direction, and I can use the same equations. Just keep in mind the negative symbol for the ay vector, or what are the vector that we are subtracting from a different vector, which would mean that if we are resolving a vector, then the magnitude of the vector would have a negative sign in front of that. For example, if I were to resolve this vector into one of these components, now let's say that one of the components happens to be x or y, I would just have to resolve that as ax would be negative of a times sine of whatever the angle that is. Let's take an example to see how this exactly works out. We have a beautiful example in front of us and we have two vectors, vector A and vector B. Both of them have magnitudes and both of them have a respective inclination as well. Now we need to find out what is the resultant vector, which is denoted by r, and we also need to find out the angle of inclination of both of those vectors. Let's try to solve this one. The first thing I need to do is that I need to resolve vector A into two components. So that would mean I need to find a horizontal component and a vertical component of vector A, and a horizontal and a vertical component of vector B. And then I need to find the resultant vector. So let me get started with finding the horizontal and vertical components of a vector. So the formula still remains the same. The horizontal component, which is ax, would be a cos theta, and the vertical component will be a sine theta. And what do we know in terms of theta? It's theta A because it's for the vector A. Theta A is 20 degrees, A is 53. So that would mean that AX is 53 cos 20 degrees and AY is 53 sine 20 degrees. So AX would be 49.8 meters and AY would be 18.1 meters. Let's do the same thing for B vector. So BX would be B cos theta B and BY would be B sine theta B. Sine theta B. And then we plug in those values. B is 34 cos theta B is 63 degrees and B is again 34 sine 63 degrees. The respective values will be 15.4 meters and 30.3 meters. So the horizontal components need to add up. So the horizontal component would be the resultant horizontal component, which is represented as Rx, would be the sum of AX and BX. The vertical components would be sum of the vertical components AY and BY. The resultant would be the square root of Rx squared plus Ry squared. Plugging the values, Rx, the horizontal component, the horizontal resultant component is 65.2 meters and the horizontal vertical component would be 48.4 meters. So if I calculate the resultant value, that would come out to be 81.2 meters. Now I know what is the magnitude of the vector. I don't know what's the direction of it. And for that, I need to find the angle of inclination. And that is given by theta equals tan inverse Ry by Rx, right? Simple. And if I plug in the values, I get an angle of 36.6 degrees. I encourage you to try this one in terms of subtracting these two vectors. You know what to do. You just have to negate whatever the value that you're subtracting from. And in this case, it's going to be B. So when you're resolving B components, try negating all of those values and you can figure out what is the resultant value is going to be. Find out what's the value of A minus B and comment down below. If you found this video helpful, make sure to subscribe and like this video. The link to this lecture notes and more such questions are in the description below. Check that out.